So in this video, we're going to learn to use a gradient table to identify the nature of stationary points. And here's my first example. I'm going to find stationary points and their nature for this function. Then I'm going to show that the curve passes through this point. I'm going to find coordinates of all the other intercepts, and then I'm going to sketch. So this question is really demonstrating the usefulness of finding stationary points and identifying them in order to sketch. This is a cubic graph. In the past, when we've sketched cubics, we might have asked you to identify intercepts, x and y intercepts, but now we need to go a step further and make sure that we can identify and label all of the stationary points. Okay, so let's start with A, find the stationary points and their nature. To find the stationary points, I'm going to need to find f dash of x Now, I'm going to jot that down in my working. F dash of x will equal 0 for stationary points. So that's going to explain what I'm doing next. So I need to find f dash of x, and it's going to be 3x squared plus 10x minus 8. And I need to make that equal to 0. So I'm going to factorize it, and I'm going to put the 0 in here. I've already explained that in my working here. So I'm going to put the 0 in, and then let's factorize. 3x and x, it's going to be, let me see, positive 4, yes, positive 4 here and negative 2 here. So I'm going to have, oops, I don't need that. So I've got 3x minus 2 times x plus 4, and then I'm going to solve that for f dash of x equals 0. So I get 3x equals 2, x is 2/3, or x equals negative 4. All right. Now I need to find the nature of these stationary points. So now I'm going to do a gradient table. Oh, I haven't found the points, beg your pardon. First I need to find, stop that. Okay, so I've just gone and popped that into my CAS because I really didn't want to deal with that by hand. So f of 2/3 is going to give me negative 400 over 27, and f of negative 4 is going to give me 36. So I've got my two stationary points at 2/3 negative 400 over 27 and negative 436. But what I don't know at this stage is what kind of stationary points I've got. So I'm going to draw myself a quick gradient table. And what I do there is I'm going to start with my x value, and then I'm going to work out whether my f dash of x value that corresponds to x is positive or negative. That's all I need to know. I don't need to actually know what value it is. And then I'm going to just make a quick sketch of the slope. And I'm going to do that at a few different places. I'm going to have my two actual stationary points in there when x is negative 4 and when x is 2/3. So I know that that's going to give me a gradient of 0 at those points, which means my shape of my slope is going to look more or less like that. Okay, now what I'm going to do is pick an x value slightly to the left of that, in between these two, and slightly to the right of that. And remember that what I'm interested in is f dash of x. So when x, let's go to the left of negative 4, I'm going to get negative 5. Let's find our f dash of x. Can you see that? Yep, that's just there. So I will put that into this factorized form rather than back into this. Negative 5 is going to give me negative 15 minus 2 here. That's a negative number, times negative 5 plus 4. That's another negative number. So I'm going to get a positive value here, which means my slope is going to look like that. Oops, you can't see that. All right. Picking a number in between these two, the easiest one to use is 0. And I'm going to substitute that back into this original equation. 0 plus 0 minus 8 is going to give me a negative value for my derivative here, which means my slope is going to look like that. Now, if I go to the right of 2/3, a nice easy number to use is 1. And so when x is 1, f dash of x is going to be 3 plus 10, that's 13, minus 8, which is a positive value, okay? Which means my slope looks like that. So now what this does is it gives me the shape up, down, up. And this will help me to sketch, okay? But now let's go to part B. Part B of my question is, show that the curve passes through the point -1, 0. So let's do that. Part B, we need the point -1, 0. My original equation is just jotted down here. So I simply need to show that f of -1 equals 0. F of -1 is going to be, and I need to show it, not just find it. So I'm going to actually write this out. Sorry, this is not all quite going to fit. F of -1 is going to be -1 cubed plus 5 times -1 squared minus 8 times -1 minus 12. Let's quickly do that. And that's done. Sorry. All right, so I've written out these numbers in order to, because this is a show that question. So I wouldn't really want to skip from there to there. I need to show that this is going to give me a value of 0. What this question is actually doing is leading me by the hand to finding my first x-intercept. And now what I can do is find the coordinates of other intercepts. That's part C. Find coordinates of all other intercepts, and then hence I'm going to sketch. So let's find the coordinates of all the other intercepts. Well, I've got 1, so there's a couple of different things that I can do to find my other intercepts. I am going to, hang on, find a new bit of paper. Okay, so what I need to do is use the fact that I know that x is -1 gives me a y value of 0. So that means that I now can find further values by using division. But what I'm not going to do is use division here. I'm going to use equating coefficients. So I'm going back to chapter 4, where we learnt that if x equals -1 gives me a 0, then x plus 1 is a factor. And so therefore I can write this as a factor with another quadratic factor here because I'm starting with a cubic. So it's a little bit of revision here. And I'm going to use equating coefficients simply because it's the quickest way in this situation. I already know that the coefficient of x cubed is 1. So in fact, I can just leave a 1 there, and I've only got a bx plus c there to find. I mean, I could probably be pretty quick with the c as well, but let's do this the long way. So I'm going to expand my right-hand side, giving me x cubed plus bx squared plus cx. That's the x times the first 3 terms, and now the 1 times these 3 terms, plus x squared plus bx plus c, and that all has to equal this. So my x cubed equals my x cubed. I pretty much know that. My -12 is going to equal c. So I now know that c equals -12. That's from equating my constant terms. So I'm just left to find the b. Now I know that b plus 1 is going to be the coefficient of x squared once I collect these terms. So I also know that b plus 1 is going to equal 5, which gives me b equals 4. Now let's double check that using the x terms. C plus b should give me the coefficient of x. So -12 plus 4 gives me gives me -8, which is the coefficient of x. So I'm good. All right, so now I know that this whole thing equals x plus 1 times x squared plus 4x minus 12, which is a quadratic which I can factorize. So I need -12, it's going to be plus 6 and minus 2. That multiplies and adds. Yep, okay. So I can find the other two, not stationary points. I'm now looking at x-intercepts. So this is f of x. I've rewritten f of x in this form. So to find x-intercepts, I let f of x equal 0. So I get 0 equals x plus 1, x plus 6, and x minus 2, which gives me x equals -1, x equals -6, and x equals 2. Sorry, that's a bit squished. Notice that I wrote this working out. I'm finding x-intercepts, therefore I'm letting f of x equal 0. I don't want to just throw a 0 on there without explaining what I'm doing. So now I have found the 3 x-intercepts of the graph. I've found 2 stationary points, and I know what they are. I know that this one here is going to be a local max. Sorry, you can't see that. A local max. And this one here is going to be a local min. So I'm ready to do my last part of this question, which is sketching the graph. So what I've done is I've quickly summarized that information, and what I've also done is I've rewritten -400 over 27 as -14 and 22/27 to help me sketch, because I need to know the approximate size of this number so that I can compare it to the y-intercept, and I know if it's going to be below or above the y-intercept. So I'm going to have a local, no, let's look at x-intercepts first, at -6, at -1, and at 2. This is a rough sketch, okay? Then I'm going to have a maximum at -4. It's about there, somewhere here. It's going to be at -436. Let's put it in. So I know that that's 36. -14 for my local minimum has to be a lot closer to 0 than that. So I'm going to pop it in. It's going to be at 2/3. This is 2, so 2/3 will be somewhere here. Let's pop it in. And my y-intercept at -12 is going to be, sorry, you've missed that. My y-intercept is going to be not too much closer, all right? So it's going to be somewhere there. So let's sketch that. All right, not too bad. Mark in all my points. And -436. So notice that when I did that sketch, I didn't do any measuring, but I was approximate in my scale, that here's -1 and -6 is out here, and this is -4. My -12, so this is going to make about 3 of these up to +36 here, all right? And then the -14 and a bit is just a bit further down. Okay, I think it's time to stop there. There will be another worked example, but if you're happy with that, you can stop there.